The Karman Line is a proposed conventional boundary between Earth's atmosphere and outer space, set by the international record-keeping body FAI at an altitude of 100 kilometers, which is 54 nautical miles, 62 miles, 330,000 feet above mean sea level. However, such definition of the edge of space is not universally adopted. The Karman Line has no particular physical significance in that there is no noticeable difference between the characteristics of the atmosphere above and below it. But it is important for legal and regulatory purposes since aircraft and spacecraft are subject to different jurisdictions and legislations. International law does not define the edge of space or the limit of national airspace. The line lies well above the altitude reachable by a conventional airplane or a high-altitude balloon and is approximately where satellites, even on very eccentric trajectories, will decay before completing a single orbit. While experts disagree on exactly where the atmosphere ends and space begins, most regulatory agencies, including the United Nations, accept the FIA's Karman Line definition or something close to it. As defined by the FAI, the Karman Line was established in the 1960s. Various countries and entities define space's boundary differently for different purposes. The Karman Line is named for Theodor von Karman, a Hungarian-American engineer and physicist who was active in aeronautics and astronautics. In 1957, he was the first person to attempt to calculate a theoretical limit of altitude for spaceflight. Definition: the FAI uses the term Karman Line to define the boundary between aeronautics and astronautics. Aeronautics, for FIA purposes, aerial activity including all air sports within 100 kilometers of Earth's surface. Astronautics, for FAI purposes, activity more than 100 kilometers above Earth's surface. Interpretations of the definition. The expressions edge of space or near space are often used by, for instance, the FIA in some of their publications to refer to the region below the boundary of outer space, which is often meant to include substantially lower regions as well. Thus, certain balloons or airplane flights might be described as reaching the edge of space. In such statements, reaching the edge of space merely refers to going higher than average aeronautical vehicles commonly would. There is still no international legal definition of the demarcation between a country's airspace and outer space. In 1963, Andrew G. Haley discussed the Karman Line in his book, Space Law and Government. In a chapter on the limits of national sovereignty, he made a survey of major writers' opinions. He indicated the inherent imprecision of the line. The line represents a mean or median measurement. It is comparable to such measures used in law as mean sea level, meander line, tide line, but it is more complex than these. In arriving at the von Karman jurisdictional line, myriad factors must be considered, other than the factor of aerodynamic lift. These factors have been discussed in a very large body of literature and by a score or more of commentators. They include the physical constitution of the air, the biological and physiological viability and still other factors which logically join to establish a point at which air no longer exists and at which airspace ends. Karman's comments. In the final chapter of his autobiography, Karman addressed the issue of the edge of outer space. Where space begins can actually be determined by the speed of the space vehicle and its altitude above the Earth. Consider, for instance, the record flight of Captain Ivan Karl Kincheloe, mispronounced, in an X-2 rocket plane. Kincheloe flew 2,000 miles per hour, which is 3,200 kilometers per hour, at 126,000 feet, 38,500 meters, or 24 miles up. This altitude and speed, aerodynamic lift, still carries 98% of the weight of the plane, and only 2% is carried by inertia, or Kepler's force, as space scientists call it. But at 300,000 feet, 91,440 meters, or 57 miles up, this relationship is reversed because there is no longer any air to contribute lift. Only inertia prevails. This is certainly a physical boundary where aerodynamics stops and astronautics begins. And so I thought, why should it not also be a jurisdictional boundary? Andrew G. Haley has termed it the Karman jurisdictional line. Below this line, space belongs to each country. Above this level, there would be free space. Technical considerations. An atmosphere does not abruptly end at any given height, but becomes progressively less dense with altitude. Also, depending on how the various layers make up the space around the Earth are defined, and depending on whether these layers are considered part of the actual atmosphere, the definition of the edge of space could vary considerably. If one were to consider the thermosphere and exosphere part of the atmosphere and not of space, one might have to extend the boundary of space to at least 10,000 kilometers or 6,200 miles above sea level. The Karman Line, thus, is a largely arbitrary definition based on some technical considerations. An aircraft can stay aloft only by constantly traveling forward relative to the air, rather than the ground, so that the wings can generate aerodynamic lift. The thinner the air, the faster the plane must go to generate enough lift to stay up. At very high speeds, centrifugal force, Kepler's force, contributes to maintaining altitude. This is the virtual force that keeps satellites in orbit without any aerodynamic lift. As altitude increases and air density decreases, the speed to generate enough aerodynamic lift to support the aircraft weight increases until the speed becomes so high that the centrifugal force contribution becomes significant. At a high enough altitude, the centrifugal force will dominate over the lift force, and the aircraft would become effectively an orbiting spacecraft instead of an aircraft supported by aerodynamic lift. In 1957, von Karman presented a paper in which he discussed aerothermal limits to flight. The faster aircraft fly, the more heat they would generate due to aerodynamic heating from friction with the atmosphere and adiabatic processes. Based on the current state of the art, he calculated the speeds and altitudes at which continuous flight was possible, fast enough that enough lift would be generated and slow enough that the vehicles would not overheat. The chart included an inflection point around 275,000 feet, or 52.08 miles, 83.82 kilometers, above which the minimum speed would place the vehicle into orbit. The term Karman Line was invented by Andrew G. Haley in a 1959 paper. Based on the chart in von Karman's 1956 paper, but Haley acknowledged that the 275,000 feet limit was theoretical and would change as technology improved. As the minimum speed of von Karman's calculations was based on the speed-to-weight ratio of current aircraft, namely the Bell X-2, and the minimum speed based on current cooling technologies and heat-resistant materials. Haley also cited other technical considerations for the altitude, as it was approximately the altitude limit for an air-breathing jet engine based on current technology. In the same 1959 paper, Haley also referred to 295,000 feet as the von Karman line, which was the lowest altitude at which free radical atomic oxygen occurred. Alternatives to the FAI definition. The U.S. Armed Forces definition of an astronaut is a person who has flown higher than 50 miles above mean sea level, approximately the line between the mesosphere and the thermosphere. NASA formerly used the FAI's 100-kilometer figure, though this was changed in 2005 to eliminate any inconsistency between military personnel and civilians flying in the same vehicle. 3 veteran NASA X-15 pilots, John B. McKay, William H. Dana, and Joseph Albert Walker, were retroactively to posthumously awarded their astronaut wings, as they had flown between 90 kilometers and 108 kilometers during the 1960s, but at the time had not been recognized as astronauts. The latter altitude, achieved twice by Walker, exceeds the modern international definition of the boundary of space. The United States Federal Aviation Administration also recognizes this line as a space boundary. Suborbital flight. Suborbital flight occurs when a spacecraft reaches space, but its velocity is such that it cannot achieve orbit. Many people believe that in order to achieve spaceflight, a spacecraft must reach an altitude higher than 100 kilometers above sea level. Works by Jonathan McDowell, Harvard Smithsonian Center for Astrophysics, and Thomas Gangel, University of Nebraska-Lincoln, in 2018 advocated that the demarcation of space should be at 80 kilometers, 50 miles, 260,000 feet, citing as evidence von Karman's original notes and calculations, which concluded the boundary should be 270,000 feet. confirmation that orbiting objects can survive multiple pedigrees at altitudes around 80 to 90 kilometers, plus functional, cultural, physical, technological, mathematical, and historical factors. More precisely, the paper summarizes. To summarize, the lowest possible sustained circular orbits are at of order 125 kilometers altitude, but elliptical orbits with pedigrees at 100 kilometers can survive for long periods. In contrast, Earth satellites with pedigrees below 80 kilometers are highly unlikely to complete their next orbit. It is noteworthy that meteors, traveling much more quickly, usually disintegrate in the 70 to 100 kilometer altitude range, adding to the evidence that this is the region where the atmosphere becomes important. These findings prompted the FAI to propose holding a joint conference with the International Astronautical Federation in 2019 to fully explore the issue. Another definition proposed in international law discussions defines the boundary of space as the lowest pedigree attainable by an orbiting space vehicle, but does not specify an altitude. This is the definition adopted by the U.S. military. Due to atmospheric drag, the lowest altitude at which an object in circular orbit can complete at least one full revolution without propulsion is approximately 150 kilometers, or 93 miles, whereas an object can maintain an elliptical orbit with a pedigree as low as 90 kilometers, 56 miles without propulsion. The U.S. government is resisting efforts to specify a precise regulatory boundary. For other planets, while the Karman Line is defined for Earth only, if calculated for Mars and Venus, it would be about 60 kilometers, 50 miles, and 250 kilometers high, respectively. In popular culture, in 2014, Oscar Sharp directed The Karman Line, a British live-action drama short film starring Olivia Colman as Sarah, a wife and mother who suddenly starts levitating until she slowly and eventually crosses the eponymous Karman Line and into outer space. See also Armstrong limit, altitude where water boils at body temperature.